Hello everyone, how to solve this problem for the values of a if we have a square root of a plus 3 is equals to square root of a. And here we solve this problem for two methods. I hope so you like both of these methods. So here our first method with the graphical method, and in the first method I can solve this problem for graphically. So here I hope so you like both of these two methods. But if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And here in graphical sense, we just suppose our left hand side is equals to some other term, that is x1. We will choose x1 is equals to square root of a plus 3, and we will choose x2 is equals to square root of a only. And if or when we draw the graphs of these two terms, then you see here our graphs will be lies in this form. Okay, so here you see that this is our origin, and this is the x-axis, positive x-axis, and this is the positive y-axis, and this is our point is 1, this point is 2, 3, and up to so on in the same pattern. Here you have this point is 0, this point is 1, this point is 3. Okay, sorry, this point is 2 and this point is 1. This is 1, 2, and 3. So here now when we make the graph of the above two functions, so you see here the graph of x1 is always lies 3 units above the graph of x2. Okay, so if I can make the graph of this term, so that the graph of this is start from 3 units away from origin, and we just draw the graph, and its graph is looks like in this form. Similarly, so if you can draw the graph of square root of a, so the graph of square root of a is starting from origin, and this is our origin, and this graph should be lies in this form, in this way. Okay, so it is move upward, but here you remember one thing is that the upper graph is always 3 units above the lower one. Okay, this graph, and the difference between these two graphs are 3 units. So here this is the graph of x1, this is the graph of x2, and we know about that any question has solution only when both of these two graphs are intersect each other. But here you see that these two are parallel graphs, and these are never meet each other. So here finally we conclude about the solution set of this problem is that this question has no solution in general. Okay, because you see here in the graphs both of these two graphs are not intersect each other, and also these are parallel, so we can say that this question has no solution. And now here we can just solve this problem for second method, and this is the our traditional method. And in this method here we first copy down given question statement. Here it is square root of a plus 3 is equals to square root of a. So if in your exam the question is that you need to find the values of a, then you can solve you can use the second method. And if you in your exam you just determine the solution, then you focus into the first method. So here in the second method we need to take a squaring on both of the sides, and when we will take squaring, it will be written as square root of a plus 3 whole square is equals to square root of a and its whole square. And in the left hand side we will just use the nice algebraic formula. You know about that. If we have square root of a square plus 3 square plus 2 times of square root of a into sorry, this is 3 only, and this is equals to this 2 and square root are gone, and we will get here a only. So here again this 2 and this square root are cancelled out by each other, and we get a, and this 3 square becomes 9, and this 2 times 3 becomes here 6 times of square root of a, and this is equals to a. So here we move this a to from left hand side to the right hand side, and it will becomes 9 plus 6 times of square root of a is equals to a minus a. So these two are also cancelled out by each other, and we get here this is 9 plus 6 times of square root of a is equals to 0. So here we solve this problem for the values of a, so that's why we move this plus 9 to the right hand side, and it will become 6 times of square root of a is equals to minus 9. And now for the values of a, we need to remove 6 from left hand side, and for this we divide both of the sides by 6. And when we divide both of the sides by 6, it will be written as in this form. These 6 and 6 are gone, and we will get here square root of a is equals to, these two are cancelled out by each other, and we get 3 3s are 9 and 3 2s are 6. So we will get here minus 3 over 2. And now for the values of a, we need to take a squaring on both of the sides, and we will get here a is equals to, the square of minus 3 becomes 9, and the square of 2 becomes here 4. So this is the only one value of a which we get here in this method. And in the next step, we need to verify that is this value of a is satisfied our given question statement or not. So for this, we need to copy down given question statement. It is square root of a plus 3 is equals to square root of a. And here we substitute the above value of a on both of the sides, and we check its behavior. The value of a is 9 divided by 4 plus 3 is equals to, this is also 9 divided by 4. And after that we need more simplifications, and we have the square root of 9 becomes 3, and square root of 4 becomes 2, and plus 3 is equals to, this is also becomes 3 over 2. So here we need to take the LCM of this term, and its LCM becomes here 2 plus 6 is equals to 3 over 2, and we obtain here this is 9 divided by 2 is equals to 3 over 2. And you see here clearly both of the sides are not equal. So if both of the sides are not equal, this means that the value of a is not satisfied our given question statement. So we just called that a is equals to 9 over 4 be the extraneous root of the given equation. Okay, this is the extraneous root, and here we cannot get any value of a which is satisfied our given question statement. So we call that our given question has and no solution. This is our final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.